So the key things we're going to be talking about today is we'll start off with some design basis criteria in terms of what design criteria, which standards and which building codes that as we kind of go through some of the design examples, we'll be basing the discussion here today on. We'll also talk about some of the key changes specifically as they apply to the concrete masonry design and construction criteria, and then more specifically as they relate to the design of foundations and retaining walls using concrete masonry construction. We'll go through a couple different examples, and these examples use both allowable stress as well as strength design, which are both design methodologies covered within the reference standard for masonry construction. And then we'll talk about some practical detailing solutions as we get into some of these typical below grade applications, many of which can also be extended to above grade masonry construction as well. So when we talk about the design basis, as we get into the design examples that we'll cover here today, I did want to let everyone know that the design examples will be specifically based upon the 2013 edition of the Masonry Standard. This is the TMS 402 ACI 530.1 ASCE 5 standard. But we'll also talk about some of the different changes that have precipitated through this standard, beginning with the 2008 version, going through the 2011, and kind of recognizing that different areas of the country, different areas of the world may be using different versions of this standard that's implemented and enforced currently. We'll also review very briefly some of the criteria for foundations and basements as they apply to concrete masonry construction. That's in the 2015 International Building Code. I predominantly kind of focused on the 2015 as the criteria that we're going to be looking at here today hasn't really changed a whole lot over the previous versions of this code. So it's pretty much applicable even if we go back through the previous versions of the IBC. And we'll briefly kind of mention some of the applicable requirements that are drawn from the design standard, the ASCE 7 criteria that's referenced in the International Building Code. So starting off with the 2015, and as I mentioned before, a lot of the criteria that we're going to be looking at very briefly here is also applicable with earlier versions of the International Building Code. The key things as we look at the International Building Code as they apply to the design and construction of pretty much any kind of load-bearing foundation type of system is the design pressures that we're going to be either permitted or required to use. If we have situations where our foundation walls are supported top and bottom, the IBC would require that in these situations we design for the at-rest design pressures. In cases where we have retaining walls or other types of structures that are not supported at the top, then we're generally permitted to be designing for active pressures. These are the reduced pressures, that is the shear strength of the soil begins to be engaged, relying upon less wall to resist some of those lateral loads. Now, I would point out that there's also an exception that's applied to these design loading criteria that applies for relatively small or small height foundation walls, those that have less than 8 foot of wall below grade, in which case these, if they're supported at the top by typically a wood or a flexible type of diaphragm system or floor system, are permitted to be designed for the active design pressures. Now, I'm often asked, what's the genesis of this exception? And a lot of it's anecdotal, a lot of it's historical, based upon just the field performance of similar types of foundations supported by light frame or flexible diaphragm types of constructions that have historically been designed for these active earth pressures, have performed very well, and hence kind of the genesis of some of this exception specifically. So kind of moving on to the specific design pressures, whether we're looking at the at-rest or active earth pressures. The IBC lists these out for us, and of course they do vary depending upon what type of backfill soils that we have. Again, depending upon whether we have active earth pressures or at-rest earth pressures. Now, I did also want to mention what's in ASCE 7, which has a very similar table to what's in the IBC for these different types of soils and the resulting at-rest or active earth pressures resulting from both. One of the key things to kind of point out is that although the tables are similar, they're not exactly the same. They do have slightly different loading criteria depending upon whether you're looking at the at-rest or active earth pressures. The general conclusion is if you're looking at ASCE 7, the loads in there in that reference standard are going to be a little bit more conservative or a little bit higher than what you're going to see in the IBC criteria for the same types of loading conditions or same types of backfill soils.